Hey, I've shown you how to wedge sims and then make flipbooks. Let's look at how we can wedge multiple attributes and then maybe split the montage so you get different flipbooks. So basically I have a switch that drives either a box or a sphere, and I'm using this switch attribute which I'm creating in this wrangle. So what I'm saying is switch equals 1 when this shape matches sphere. And this shape attribute I'm creating in this first wedge here. So wedging shape, first value is box, first value is sphere. And the second thing I'm wedging is the velocity, which I've called speed, and I'm just giving it some random velocity from -1 to 1. So let's cook these. And basically this index, I'm just storing the wedge index here, so I have a constant value from 0 to 1 down the chain, so I can use it later down the line. So that was the way I did it when I built this, but technically when we get down here to partition by origin index, which is this, I could also partition by this shape attribute, but this is fine, so we'll keep it at this. So now let's step through my work items. So let's be here, I'm gonna put the output flag here so I can click on these. So the second wedge, I have my sphere and its velocity is set here. And I'm just putting it inside of .NET. It bounces like and then breaks. Then that I'm importing with the dot imports. I'm just caching the points and then I'm caching those. And I've set my path to be GeoRBD P at shape, so either sphere or box, and then the wedge index, so from 0 to 3 since I have 4 wedges. And then I'm caching this out, reading that back in, then using transform pieces, and this out null is what we're going to use for the OpenGL render. Let's go inside the topnet, and then so I have here the rob fetch, which is going to cache all these to disk like we've done before. Nothing special here. Then I have this OpenGL rob, which is in this robnet, which is the same, and then I'm making the output image just RBD P at shape, P at wedge index, normal stuff. Then I'm creating this montage partition attribute, which is P at shape and then P at frame. And that's because when I get to image magic, what I want to do is 2 sequences. Basically, one would be the 2 wedges of the box and one would be the 2 wedges of the sphere. So if I were to generate here this node, I have 80 frames here because I have 4 times 20, and then I'm partitioning this, and now this means I get 40 work items. And if I look at this rectangle here, which is this partition, I get RBD box 0 frame 1, RBD box 1 frame 1, exactly what I want. So when that goes into the image magic, I will get basically 2 sequences of 20 frames, one for the box, one for the sphere. And then I'm sorting by the frame, so that when I get here, I have frame 1 and then frame 1 and then frame 2, because if you look at it here, this one is 1010 because it's being partitioned by this montage attribute, which is a string, and so I need to sort it afterwards. So I sort it by the frame, pop this into this origin index which I've created here, but I could very well just use this shape attribute, and then this goes into the FFmpeg encode video. So let's run this whole network. So here's the video of the box, 2 wedges of the box. Here's the video of the sphere, 2 wedges. So there we have it. Let's go through the network one more time. Making a wedge for the shape, which is driving the switch over here. making another wedge for the speed. As you can see, I'm making 2, but it goes 2 times 2, right? So the box is 2 wedges, and the sphere has 2 wedges as well for this speed attribute. Caching that with a ROP fetch, making an OpenGL render with this ROPNet and this OpenGL ROP, creating this montage partition attribute, which is based on this shape attribute and the frame attribute, so that when I pipe this into the partition by attribute, I get 40 partitions. Piping that into ImageMagick, sorting by the frame attribute, partitioning by this origin index, which I've created here, which is basically the same as the shape. I could have used the shape. And then piping that into FFmpeg encode video to make a nice little MP4.